Thanks to Brilliant for supporting this episode of SciShow. Go to brilliant.org/scishow to learn how you can take your STEM skills to the next level this year. You might not be able to see this, but the Earth is breathing. Every day, living things take up carbon dioxide and release oxygen as a part of the processes that keep them alive. And that is great for us because ecosystems all over the planet have been silently mopping up the excess carbon we release from driving, flying, and just generally living our lives. In fact, ecosystems on land alone currently absorb about a third of human-made carbon emissions. But according to a paper published last week in the journal Science Advances, that's likely to change in the next few decades. Instead of helping fight climate change, they could end up accelerating it. And if that happens, we will only have ourselves to blame. Plants suck up carbon dioxide from the atmosphere and water from the soil, then use that sunlight to turn those ingredients into sugar molecules and oxygen. That's photosynthesis in a nutshell, and you can kind of think of it like an ecosystem's breath in. Those sugars are then broken down to make cellular fuel, either by the plant, by something that ate the plant, or by decomposing organisms after the plant dies. And that process turns some of that carbon back into carbon dioxide, much of which gets released into the air. That is respiration, or to continue the metaphor, the ecosystem's breath out. But how fast photosynthesis and respiration happen depends on temperature. That's because both of the processes rely on enzymes to speed up the chemical reactions involved. A higher temperature means faster moving molecules and a higher likelihood that enzymes run into their targets. Eventually, though, the enzymes top out. They simply can't go any faster, and in fact, the heat starts to mess them up, so the reactions they help with slow down again. But here's the rub. Photosynthesis and respiration don't speed up or slow down at the same rate, partly because they use different enzymes, each with their own optimum temperature. And if, on a larger scale, there ends up being more breathing out than breathing in, more carbon dioxide goes into the atmosphere than out of it. The researchers behind this new study wanted to know how the rates of photosynthesis and respiration might change as global temperatures change. So they turned to a massive global network of more than 800 carbon monitoring stations called FluxNet. FluxNet stations record the local daily temperature as well as how much carbon was exchanged between the atmosphere and the Earth. From those data, the team could map changing photosynthesis and respiration rates to temperatures, first locally and then globally. What they found was that photosynthesis maxed out at 18 degrees Celsius for plants like trees, rice, and wheat, and 28 degrees for ones like sugarcane and corn. But respiration rates just keep increasing. In fact, according to mathematical extrapolations, respiration doesn't top out until 60 or 70 degrees Celsius. Most importantly, by around 25 degrees, there is more respiration than photosynthesis. So that's the tipping point when an ecosystem ends up putting more carbon into the atmosphere than they take out of it. Right now, about 10% of ecosystems reach that point for at least a little while every year. But if there's no change in our carbon emissions and global temperatures increase as expected, then by 2100, more than half of all land ecosystems could be past that tipping point. And it gets worse. The places on Earth first to tip over will be the ones that currently breathe in the most carbon, like parts of the Amazon rainforest and the taiga forests of Russia and Canada. They alone account for some 40 to 70% of the carbon pulled from the atmosphere by ecosystems on land. And that means the global tipping point, when land plants start to spit out more carbon than they use, will be more like 2040. Now, it's possible that Earth's plants could evolve and adapt their cellular processes to tolerate hotter temperatures, but the researchers think that 2 decades just isn't enough time for that. And though experiments suggest that increased carbon dioxide can fuel photosynthesis, they didn't see any evidence of that in their data set. But it's not all bad news. There's evidence from other studies that ocean ecosystems might actually be getting better at absorbing CO2 thanks to less churning up of the water. And they currently absorb at least 40% of our carbon emissions. Still, we should not be thinking of that as a failsafe. It's also possible that we will overwhelm the ocean system. So we still need to rein in the global temperature rise to less than 2 degrees Celsius, or even better, less than 1.5. Luckily, we already know how to do that by doing what we can to reduce our carbon emissions. Making these kinds of predictions about the future is always tricky, but anyone can learn the statistics that underlie this kind of research, especially with a little help from Brilliant. Brilliant takes a hands-on problem-solving approach to teaching STEM topics, and their courses are available through their website and through their iOS and Android apps, so you can enjoy learning from the comfort of your own home on the device of your choosing. I'm excited to check out their new Introductory Statistics course. It pulls back the curtain on stats, so you'll learn how scientists and engineers make decisions without having literally all the data. I'm really interested in the part that understanding statistics can play in general education and also making the populace better at understanding our world together. So I'm always looking for good statistics courses. With an annual premium subscription, you will get access to that and their other 60+ courses. And since you watch SciShow, you can actually get 20% off the annual price. All you have to do is go to sign up at brilliant.org/scishow.